All right, guys. Um, let's um, let's talk about specific pathways. So, um, the first set of pathways we're going to talk about are all G protein linked receptors. Um, although a lot of these, like cyclic AMP, can actually be turned on by other receptor types, but we're going to talk about them um, in terms of G protein linked receptors. So if you know what we've already talked about in terms of how do you activate the G protein linked receptor from the point of the signaling cell releases a signaling molecule to the point of the alpha subunit separates from the beta gamma subunit, you already know most of the pathways. All right? The first one we're going to talk about is cyclic AMP. Cyclic AMP is a very common um, second messenger, and um, it is produced in response to adrenaline and acetylcholine and other things as well. Um, like we said before, different cells are going to respond to the production of cyclic AMP in the cytosol in different ways, and that's going to be due to the specific enzymes that are activated by cyclic AMP that are present in the cytosol. So a muscle cell will respond by breaking down glycogen to glucose, and a fat cell will respond by breaking down triglycerides to fatty acids, and the adrenal gland will respond by secreting cortisol. And in this way, adrenaline can cause a system-wide response very quickly so that you can run away from the lion, right? Cyclic AMP is a derivative of um, ATP. It's produced from ATP. Um, so you can see here is the phosphate group, and it's produced by the enzyme adenylyl cyclase. So adenylyl cyclase takes the molecule ATP, it cleaves off two of the phosphates, and it creates this ring. All right, so you see the ring? So that's why it's cyclic. Cyclic AMP. Now, cyclic AMP is degraded very quickly in the cell. Remember, we always have to turn off our signaling molecules so we don't have bad things happen. We don't over amplify our signal. And so cyclic AMP is degraded by cyclic AMP phosphodiesterase, so it cleaves the phosphate bond. And the cyclic AMP phosphodiesterase is ubiquitously produced. It's always present in the cytosol. So as soon as cyclic AMP is produced, it begins to be degraded. So if the signal from cyclic AMP is going to be propagated, you have to continue to produce cyclic AMP. Cyclic AMP acts on PKA, which is cyclic AMP dependent protein kinases, okay, or protein kinase A, okay, protein kinases activated by cyclic AMP. Um, PKA is going to phosphorylate other proteins, okay? So a couple of things I want you to think about. What is the substrate of adenylyl cyclase? And also, I want you to think about how do you know that protein kinase A, or PKA, is going to phosphorylate something? Right? So, in a signaling cascade, or in this signaling cascade, you're going to have a extracellular signaling molecule that binds to the G protein linked receptor. Binds to the G protein linked receptor. which is going to cause the GEF activity to be activated, which is going to cause the G protein to switch the GDP for the GTP, which is going to cause the alpha subunit to separate from the beta gamma subunit, which is then going to bind the in this case, actually either, there have been different situations where it's been found that both the beta gamma subunit can activate adenylyl cyclase or the alpha subunit. But by far more commonly, the alpha subunit activates adenylyl cyclase. So the alpha subunit binds to and activates adenylyl cyclase, which uses ATP to produce cyclic AMP. Cyclic AMP is going to activate protein kinase A, and protein kinase A goes on to phosphorylate other proteins, and eventually you'll get some kind of cellular response. Okay? So this is our ... It depends on what is present in the cytosol, what happens next. All right, you might want to go over this in your textbook. This is a little bit of a complicated pathway. Phosphatidylinositol is a phospholipid that is only found in the cytosolic monolayer of the plasma membrane, and its primary function is in cell signaling. Phosphatidylinositol, I'm not going to go over this part of the pathway where you get 3 phosphates added to it, but we're going to start here. So, so in the phosphatidylinositol pathway, you have a G protein linked receptor that's activated by an extracellular signaling molecule that's going to activate your G protein, and the G protein is going to expel its GDP and get a molecule of GTP. So it's going to become active, and the alpha subunit will separate from the beta gamma subunit. And in this case, the alpha subunit is going to activate the effector, or the enzyme, PLC, which is phospholipase C. Okay? Phospholipase C. So phospholipase C is a molecule that's going to cleave phosphatidylinositol. Okay, remember, phosphatidylinositol is a phospholipid. And as a phospholipid, it has 2 major parts. It has the hydrophobic part, where you have 2 fatty acids attached to a glycerol, and you have the hydrophilic phosphate head. Phospholipase C is going to cleave the hydrophilic part of phosphatidylinositol from the hydrophobic part. So what you end up getting is diacylglycerol, which is here. Diacylglycerol are the 2 fatty acyl groups connected to the glycerol, diacylglycerol, and you have your hydrophilic inositol triphosphate. Okay, inositol sugar with 3 phosphates. Inositol triphosphate. Now, inositol triphosphate, I love you too, hello. Oh, okay. You're gonna kiss me on my lips? You're gonna give me a sloppy kiss? Mm. Thank you. I need you to be quiet now, okay? If you're going to stay here, you need to be quiet. All right, so so phospholipase, where's my arrow? Phospholipase C is going to cleave phosphatidylinositol into its hydrophobic portion, which is diacylglycerol, and its hydrophilic portion, which is phosphatidylinositol. I said you need to be quiet if you want to stay here. Otherwise, you can go downstairs.
Go, Mama.
Oh yeah, see, there you go. Diacylglycerol and inositol triphosphate. All right, so here's another picture which is a little more simple.
I'm gonna go now,
Okay, have fun. Um, so we already did this. The signal molecule binds to the G protein linked receptor. The GEF activity activates your G protein. The alpha subunit, the active alpha subunit activates phospholipase C, which causes inositol triphosphate to become cleaved into diacylglycerol and inositol triphosphate. Now, both diacylglycerol and inositol triphosphate are necessary to activate PKC. Okay, so what we're trying to do is activate this PKC molecule, protein kinase C. I'm not sure where the C comes from, whether it has to do with the calcium or that has to do with the phospholipase C. Anyways, it's PKC. So these two things happen simultaneously. The IP3, which is hydrophilic, diffuses to the endoplasmic reticulum and it binds to calcium ion channels, which stimulates them to open and release calcium ions into the cytosol. Okay, so IP3 activates calcium ion channels. IP3 is going to go to the endoplasmic reticulum. Remember, the smooth endoplasmic reticulum is like a reservoir for calcium. So there's going to be calcium ion channels, and when those calcium ion channels open, calcium is going to diffuse into the cytosol because calcium concentrations are very low in the cytosol and very high in the endoplasmic reticulum. At the same time that this happens, diacylglycerol is going to attract PKC. PKC is attracted to diacylglycerol and it's going to bind to diacylglycerol at the membrane. But calcium ions must also bind to PKC for it to become activated. Okay? So, in order for PKC to become activated, you need both diacylglycerol and calcium ions. Okay? Two molecules must bind PKC in order for it to become active. Diacylglycerol must be bound to it, and calcium ions must be bound to it. Okay? Okay. All right. So, moving on. Our next set of receptors, we just talked about G protein coupled receptors. Now we're going to talk about receptor protein tyrosine kinases. Okay, receptor protein tyrosine kinases. So these are sometimes referred to as RTKs. Voila. Now I want to point out that there are protein tyrosine kinases in the cytosol that are not receptors. So it's important to qualify them as receptor protein tyrosine kinases. I think I need to go get my baby. So I'm going to stop here and I'll pick this back up in the next